So now let's do this question. Okay, find the current through the 10 ohm resistor. So here in this is a normal DC current. So this problem is very simple, right? Because there is no capacitor or inductor, only resistors. So this is a normal DC circuit. So here is a 10 ohm resistor. So what I'm going to do is that I'm using Norton's theorem. So I will remove this 10 ohm resistor and then I will short the two ends. Okay, then I will find the current through that end. Right. So let me draw the circuit. Removing 10 ohm resistor and shorting them, comma, the circuit will be like this, right? There's a voltage source and this end is now shorted. Okay, this two ends, right? This end is now shorted, right? This, then you have a resistor. Then you have a voltage source over here, then another resistor. I always tell my students to please try to do this problem by yourself, okay, without my help. This problem, I think most of you can do by yourself after doing so much videos, right? I think you can do this problem by yourself, right? This is 20 ohm, this is 30 ohm, this is 100 volt, and this is 50 volt. Okay, and so your job is to find the value of the Norton's current which is flowing from A to B, right? This is called as the Norton's current, IN. So you need to find the value of IN. Okay, so I'm going to apply mesh analysis. So if I'm going to apply mesh analysis, then this is mesh 1, so this is I1, this is mesh 2, so this is I2, and this is mesh 3, so this will be I3. Okay, and therefore I need to find the current through this branch, that is IN. But according to your mesh current, the current through this branch is also called as I1. Therefore IN is equal to I1, which means you need to find only the value of I1. If you find the value of I1, you have already found the value of IN. Okay, so let me write equation for mesh 1. Equation for mesh 1, let me see. Here I1 is touching only this resistor over here, right? So it is I1 into 20. Okay, and minus, and what about I2? I2 is also touching only the resistor. There is no other element over here, right? So it is I2 into 20 is equal to, now let's see, there are two voltage sources, right, in this equation. So this I1 current is flowing out of the positive terminal, which means this positive terminal is generating I1, therefore it is plus 50. Okay, and what about this 40 volt? This I1 is going into the positive terminal, which means this positive terminal is not generating I1, it is opposing I1, therefore it is minus 40. This is the equation. Okay, in other words, this is 20 I1 minus 20 I2 is equal to, and we have 50 minus 40 is 10. Okay, I can simplify this. Maybe I can write this as 2 I1 minus 2 I2 is equal to 1. Not necessarily, just simply, I'm just seeing if I can able to. Sometimes this equation might be more helpful than this. That depends on the equations of the other meshes. Okay, so let me write the equation for mesh 2. Equation for mesh 2, and here I2 is positive and the I1 and I3 are negative, so this is minus I1 into, and I1 is touching only this resistor, so it is 20 plus I2 into, and I2 is touching this 20 and this 20, right? It's touching all these three resistors, so that means 20 plus 20 plus 20 is 60. So I2 into 60 plus, no, not plus, it's minus, right? Minus I3 into, and I3 is touching only this resistor, that is 20, is equal to, there's a voltage source over here, right? And this I2 is coming out of the positive term, right? The direction of I2 is upwards. In this branch it is going up, right? And this 40 volt positive terminal is also in that direction, which means this positive terminal is generating I2. So therefore this is a plus 40. Okay, this is the equation. I can simplify this, right? I can divide this entire equation by 20. I will get minus I1 plus 3I2 minus I3 is equal to 2. Okay, this is the other equation. Now I'm going to write the equation for mesh 3. Okay, equation for mesh 3. Here we have, here there's a current I2, and that I2 is negative, right? Because this is mesh 3, so I3 is positive and remaining currents are negative. So it means I2 is also negative, which means it is minus I2 into 20 plus I3 into, and I3 is touching these two elements, right? This 20 and 30. 20 plus 30 is 50. So I3 into 50 is equal to, and what about the voltage source? Well, this I3 is going into the positive terminal, which means this positive terminal is not generating current, it is opposing I3, right? So it is minus 100. Minus 100, okay? Maybe I can divide this whole thing by 10. It will become minus 2I2 plus 5I3 is equal to minus 10. Okay, this is the other equation. So now I am going to apply matrix method. Okay, let me apply matrix method to find the value of I1. Okay, so therefore representing equations 1, 2 and 3 in matrix form. In matrix form, comma. So what will be my, so what is the coefficient of I1 over here? It is 2, right? The coefficient of I1 over here is 2. The coefficient of I2 in the first equation is minus 2. And the coefficient of I3 in the first equation is 0, because there is no I3 over here. So it is 0. This is actually plus 0 into I3, right? So therefore the coefficient is 0. Okay. What about the second equation? The coefficient of I1 is minus 1. The coefficient of I2 is 3. And the coefficient of I3 is also minus 1. What about the third equation? The coefficient of I1, there is no I1 over here, so therefore the coefficient of I1 is 0. Here the coefficient of I2 is minus 2, and here the coefficient of I3 is 5. Here you have the variables are I1, I2 and I3. And what about the constants? The constants are 1, 2 and minus 10. So 1, 2 and minus 10. So now I need to find the value of I1. So I1 is equal to the determinant of, I'm going to replace the first column with this. So it will become 1, 2, minus 10. Here it will be minus 2, 3, minus 2. Here is 0, minus 1, 5. Divide by the determinant of the coefficient matrix, that is 2, minus 1, 0, minus 2, 3, minus 2, 0, minus 1, 5. And then we have here is, I'm going to multiply this. So this here we have, basically we have 1 into 3 into 5 is 15, and minus this, these two will be cancelling each other, so you have plus 2, so it becomes minus 2, and this is minus of minus is plus, so plus 2 into, we have, this is 10, and we have also here is a minus and minus will cancel each other, so you have plus 10, which again it becomes minus 10, so this is also minus 10, and this is 0. This is your numerator, and the denominator is 2 into, same story over here, 15 minus 2 plus 2 into, we have 5 minus 5, 2 into minus 5 into 0, that's it, right? This is plus 0 into that, you don't have to look for that. So here you have the answer as, here is 15 minus 2 is 10 minus 10 is 0, here 15 minus 2 is 13, so we have 13 over here, divide by, and here you have 2 into 13 minus 10, or you have over here 13 by 26 minus 10 is 16. So which means you have basically 0.813 amperes. 0.813 amperes. This is the value of I1. Therefore, IN is equal to I1, which is equal to 0.813 amperes. So now you found the Norton's current. Next you're going to find the Norton's resistor, right? There's no need of calling it impedance because only resistors are here, right? So it's actually Norton's resistor, Rn. Okay. So to find Rn, right, next page. Where do we? Next page. To find Rn, comma. Here the circuit is, if you see any voltage source you should short it, and if you see any current source you should open it, and you should find the value of Rn across these two terminals, right? So it is like this. Okay, find the resistors across Rn. Okay, here there is nothing, just simply short it. Here you have a resistor and then you can join it to the ground. So you have only a single resistor, right? Over here, a single resistor. Okay, then we have another resistor and another resistor over here. Okay, then you have another resistor over here, then you can short it. This is your circuit to find Rn. 30, 20, and all remaining are 20. This is 30 ohm, this is 20 ohm, this is 20 ohm, and this is 20 ohm. Okay, so now you're going to find the value of Rn. Okay, that's what you need to find over here, right? Okay, so I have not missed any resistors over here, right? 1, 2, 3, 4, right? There's no other resistors. 1, 2, 3, 4. Okay, so basically how are you going to do this? Start small, start very simple, right? Don't look at the look at something which you are very sure of. For example, you can be sure that these two resistors are in parallel, right? Because these two resistors have the same connection at both ends. These two resistors are connected together, and at this end these two resistors are also connected together, which means these two resistors are in parallel to each other. So therefore I can combine these two resistors, right? So let me combine these two resistors. So if I'm combining them, I will get 30 into 20 by 30 plus 20, which is basically 600 by 50, which is basically 600 divided by 50 is actually 12. Okay, so this is actually 12. So therefore I can now simplify the circuit. This is my circuit. Okay, this is 12 ohms, this is 20 ohms, and this is 20 ohms. Okay, and this is the value of Rn. Okay, so now, like again I'm saying that these you see, now you'll be confused, so don't look at these two anywhere. Okay, but you can be rest assured of these two, right? These two are in series to each other. You see, they're connected in an end, which means the current that goes through 20 ohm is the same current that goes through this 12 ohm, right? So which means these two resistors are in series, so which means I'm going to add these two resistors. Okay, so adding them will become 20 plus 12, which is 32, right? 32. 20 plus 12 is equal to 32 ohms. So which means you have, here is the resistor in this format, right? We have the 20 ohm over here, and then you have these two resistors are combined together, so you have a 32 ohm, right? 32 ohm. Okay, so now if you look over here, this end of the resistor is connected to A, right? This end of the resistor is also connected to A. this end of the resistor is connected to B and this end of the resistor is also connected to B, which means these two resistors are basically in parallel to each other. So therefore Rn, your Norton's resistance, is equal to, it's actually 20 parallel 32, okay, 20 parallel 32, or in other words it is 20 into 32 by 20 plus 32, or basically this is actually 640 by 52, 640 by 52, which is 12.308, 12.308 ohms. Okay, so which means now your Norton's equivalent is Norton, Norton's equivalent is like this, right? That means I draw a current source over here, then I draw a parallel resistor, which is the Norton's resistor over here, okay, and what is the value of IN? My IN is 0.813 amperes. So this is 0.813 amperes, and this Rn is 12.308, 12.308 ohms. Okay, so what was the question? The question was find the current through the 10 ohm resistor. The 10 ohm resistor is the load, right? That is the load, that's why I removed it. So now I'm going to put the load back to its place, so therefore the load will be over here, right? The load is across A and B. This is A and this is B, right? This is 10 ohm. So you need to find the current through the 10 ohm resistor. Okay, so basically you can apply node analysis or voltage analysis or whatever analysis you want. I'm going to apply mesh analysis. I'll simply apply mesh analysis. So this is I1, this is I2, which means I need to find the value of I2. So which means here I1 is equal to 0.813 amperes, right? I1 is equal to 0.813 amperes, and I2, to find I2 you apply the mesh analysis over here. It will become minus I1 into 12.308 plus I2 into, and here it is 10 plus 12 is 22, so you have 22.308. 22.308 is equal to 0. In other words, I2 is equal to 0.813 into 12.308 by 22.308. This is the value of I2, which is basically 0.813 into 12.308 divided by 22.308, and here it is, answer is 0.449, 0.449 amperes. Therefore current through the 10 ohm resistor is equal to 0.449 amperes. This is your answer. Okay.